All right, we start again. So this is something you can run it on your own, but this is what we just described. Backtracking, if you see, is DFS plus variable ordering plus fail on violation, and this is what we did. You start with DFS, you keep on coloring variables one at a time. Whenever there is a failure, you have to backtrack. Okay. Now we want to improve backtracking. Right now, what are we doing in backtracking? Start from the root node, assign color to one variable at a time. Okay. And you keep on doing this until constraints are not violated. Okay. And if constraints are violated, backtrack. General purpose ideas give huge. So why is this faster than DFS? Again, we have talked about this before, but why is this faster than DFS? Because you don't explore the whole tree, right? You do it lesser than the whole tree. I mean, in the worst case, it will still be d to the n, but complete tree will not be explored. Ordering. So here we have the question now. What is this question? I mean, why are these questions? Why do we have these questions here? You are doing DFS with backtracking. Acha, one question. What about BFS? BFS was ruled out even before we started off. Okay, so BFS की बात हम इस बारे में नहीं कर रहे हैं. Now DFS plus backtracking, we know what it does. My question is, why do we have these two questions here? Backtracking क्या थी? We want to do DFS. And DFS में क्या था आपने करने का तरीका? I'll start from the start state. I'll choose a variable, color it. What are these two questions asking? Which variable? Right? Which variable should I choose to color? So I'll be specific to this problem. Which variable should I choose to color right now? And once I have chosen a variable, what is my next question? Which color? Red, green or blue? Okay. Can this matter?
Yes.
Can you give me an example? Previous example. We saw in that tree, right? Where was the issue? If I go this path, I know there are issues, right? But if I go this path, by the way, can you lead me to a proper assignment down this path? Can you just help me figure out? Red, green, red, green, and red. So alternate colors to these guys, and then I can assign SA the third one, right? So in this case that will be blue, and Tasmania is okay with whatever. Okay, so this path gives you something. So everybody understands that which variable matters and ordering matters. Coloring problem is NP complete. Okay, what does it mean? Have you heard of this question? Have you heard of this question, P versus NP? What is it? कितना प्राइस है इस प्रॉब्लम के सिर पे? $1 million. ओके, बट ट्रस्ट मी, पीपल से कि $1 million कम है इसके लिए. So this problem has been there for last maybe 5 decades now, but there are other problems that are solving. I mean, heard of Goldbach conjecture? थोड़ा सा digression तो है. Heard of Goldbach conjecture? What is that? So Goldbach conjecture you can search, but अभी मत करो यार, अभी तो मेरे को ज्ञान दे लेने दो, है ना. Goldbach conjecture means, I mean, it states that for all primes greater than 2, sum of 2 primes will be an odd number. This is trivial, right? Because all primes greater than 2 are all odd. But it also says that every even number can be written as a sum of 2 primes. This conjecture was given in the 18th century and no solutions yet. Okay. Anyway, coming back to this. So there are problems that can be easily solved. For example, sorting, multiplication, addition, shortest path in a graph. But there are problems that will take huge amount of time to solve. For example, graph coloring. Right. So coming back to what we were discussing. Which variable should be assigned next and what order should its values be tried? Filtering. Can we detect inevitable failure early? So ये जो क्वेश्चन है ना, इसका नाम हम दे रहे हैं फिल्टरिंग. Can we exploit the problem structure? ये तो आसान है. Can you help me exploit the problem structure for this case? ये जो अपना रनिंग एग्जांपल चल रहा है. What is the problem structure in this? Tasmania is not creating any problems for me. Okay. Filtering. What was filtering? What was filtering? Can we detect inevitable failures early? If I can detect inevitable failures early, what does that mean? You don't move that path for long enough. Okay. Filtering, forward checking is, so keep track of domains for unassigned variables and cross off bad options. Forward checking, cross off values that violate a constraint when added to the existing assignment. I don't understand any of this. Okay, let's start with just this assignment. To begin, so why are we not considering Tasmania here? Tasmania does not have any constraints with anyone, so that we can solve independently. So we have these 6 here now. Okay. Now to begin with, I can assign any color to any of them. So these are my domains to begin with. What will happen? The moment you decide to color this, WA reduces to red. You have exhausted the choice among 3. This is now red. Why do we not see red here? And why do I not see red here? for the same reason. Now you tell me what will happen next. Done? Right? So if you see, this guy is left with only blue. Okay? NT is left with only blue. SA is neighbor of both, so is left with only blue, and so on. All right? Let us understand this last one. So this one WA is assigned red. That guy is nahi, एक second, कुछ तो गड़बड़ हुई ना. So for us right now, this is the right picture, right? What has gone wrong here? ये मेरे को बता दो. So SA does not have any option anymore. Why not? This guy stops red, this guy stops green, and this guy now stops blue. So SA is not left with any option. So this particular assignment, domain for SA is empty now. So ये जो आप कर रहे थे, this path, that gives you an inevitable failure. Okay? Filtering, keep track of domains for unassigned variables and cross off bad options. This is what we have done. Forward checking, cross off values that violate a constraint when added to the existing assignment. Okay? Let us go next and talk about this. Forward checking propagates information from assigned to unassigned variables but doesn't provide early detection for all failures. In this case, it was done. What happens in this case now? WA is red and Q is green, so NT can be only blue. Okay? NSW can be red or blue. Victoria, this guy can be Abhi, because none of its neighbors are colored, it can take any value. SA, because it's a neighbor of these two guys, can take only blue. Okay? So you keep on crossing off the domains for these guys. If you are left with no coloring possible for any of the variables, then you have to backtrack. कौन सा? No. What you are doing is the following. Keep track of domains for unassigned variables and cross off bad options. What you are essentially doing is cross off the values that violate a constraint when added to the existing assignments. Cross off values that violate a constraint when added to the existing assignment. That's what we are doing. We are crossing off these things. I'll take a pause here if more questions. What are we doing? Starting say, we were doing DFS, backtracking, that was working fine, better than DFS. Then we say DFS में this question is relevant, which variable do I choose and what should be the color, order of coloring. So order of variable chosen and orders of colors chosen, both are important, right? And we have seen examples of such things in that last example. Then what we are saying, the moment I am here, I won't assume that next level has all the options to them. I will keep on striking off the domains. If I am left with a situation when any of the variables can't be assigned any value, I have an inevitable failure. I must go back from there. Okay? We are still doing DFS plus backtracking. We are just keeping another data structure, another bookkeeping. I need to keep track of the remaining domains for all the unassigned variables. If there is an unassigned variable that can't be assigned anything, basically I have to backtrack. Then नाम पे मत जाओ, ये नाम बहुत सारे हैं पूरे कोर्स में. ओके, चलो. So NT and SA cannot be both blue. And why didn't we detect this? Okay. No. So there is something more to this slide compared to previous one. How is this slide different from the previous one? एक सेकंड बाद में डिस्कस करना, पहले इधर देखो. What happened in this case? See, we came from here to here. Folks, बातें नहीं इधर. We came from here to here, and South Australia is not left with any colors in the domain, so we must backtrack. Here we know for sure we must backtrack. Should we have figured it out earlier? Kab? Third step. What does third step say? For NT I am left with only blue. For SA I am left with only blue, and they both can't be same. So we should have figured it out here itself. यहाँ तक जाने की जरूरत नहीं पड़नी चाहिए थी. Okay? This is what it says. So this is what we said. All right. Now this helps us do that. So this helps us improve our forward checking. ये थोड़ा सा इन्वॉल्व टॉपिक है, ढंग से सुनना पड़ेगा. An arc x to y is consistent. Now this consistent has nothing to do with consistent heuristic. An arc x to, how many of you understand the meaning of this if and only if, this IFF? What does IFF mean? If and only if, right? But what does that mean? Huh? And what more? A implies B and B implies A. Okay? Then you use if and only if. So an arc is consistent for every x in the tail. So if for every x in the tail there is some y in the head which could be assigned without violating a constraint. ये चीज सुन लो ढंग से, मैं बहुत पूछता हूँ एग्जाम्स में, एंड ये दिमाग में घुसती भी नहीं आसानी से. So this is how you start with. Okay? What is arc in this case? X and Y are variables here. What is arc in this case? Arc is NT to WA. Okay? arc is consistent if and only if for every x. So this guy is my x, this guy is my y. If and only for every x in the tail. तो इसकी डोमेन बताना मेरे को, RGB. For every x in the tail there is some y in the head. So इसमें क्या है? Red. Some y in the head which could be assigned without violating a constraint. For every x in the tail, there is some y in the head which could be assigned without violating a constraint. True or false in this case? For every x in this, can it be assigned? No, this is false. कौन सी चीज प्रॉब्लम कर रही है? Red. If I strike off red from here, is this arc consistent now? Yes. If I ask you for this arc, is it consistent? If I ask you for, right? So you have to delete from the tail, जो अपन ने अभी किया, right? Can you give me an arc here which is consistent? Just one example. So tell me, is this arc consistent? Is this arc consistent? मैं ये एग्जाम में पूछता हूं और बहुत लोग गलती करके आते हैं और अब सेम आपके साथ भी रिपीट होगा. Is this consistent? Yes. How many go for yes? Yes or no? Yes. Yes. How many of you go for no? So no first. Why no? For all colors here, there exists a color here. If you talk about red, there is green and blue. If you talk about green, there is red and blue. If you talk about blue, there are red and green. So for every color here, you have some color here. Right? Now, this is a quantifier that you see in logic a lot. For all, and there exists. Right? So see what is written here. For every x, that means for all x in tail there is some y, so there exists a y. All right? Now tell me, is this arc consistent? Why so? Because there is only one domain for WA, which is red, and for this red there exists someone in this. Do I need to delete? Do I need to delete anything? You delete only from the tail. Okay? Any questions here? क्योंकि ये तो मैं पूछ रहा हूं एक आर्क देके कि whether this is consistent or not. हाँ. No, you delete. You don't delete from the head. You delete from the tail. Okay, so now if I ask you about this arc, is this consistent? If I ask you about this arc, is this consistent? No, because for red there are problems. So what do? Delete red. You can delete from the tail, but you don't delete from the head. More questions here. So forward checking in this case is enforcing consistency of arcs pointing to each new assignment. Arc consistency of an entire CSP. A simple form of propagation makes sure all arcs are consistent. And then again they say remember delete from the tail and not from the head. Is this consistent?
Yes, sir. Yes.
So you have to check it for all. For red there exists blue. For green, both of them. For blue, red. So this arc is consistent. What about this arc? This is consistent because for blue, that is the only color you have. ये बहुत confusions होते हैं. What you have to remember is for all x there should exist a y. Right? What about this arc? Is this arc consistent? Why not? For blue, so for red, then, but for blue there does not exist a color here. अब ये बता दो.
Yes, sir.
ये वाले are all easy, okay? So wherever you have more than one, chances कि it will be consistent are higher, है ना? Not necessarily कि ये हो गई. What about this one? Not consistent, right? So if x loses a value, remember you are deleting from the tail. If x loses a value, neighbors of x need to be rechecked. But you have deleted a color from somewhere, so you need to recheck for the neighbors of x. Arc consistency detect failure earlier than forward checking, वो जो अपन कर रहे थे last time, right? It can be run as a preprocessor or after each assignment. What's the downside of enforcing arc consistency? पहले ये आंसर दो. What are the downsides? But for your help, third वाला पढ़ो पहले. Can be run as a preprocessor or after each assignment. अरे लगाया करो यार तुम लोग. क्या बोलते हैं उसको? सीरियल नंबर. हाँ. Yes, coming back to this. Can be run as a preprocessor or after each assignment. And then, what are the downsides of enforcing arc consistency? Give me the time complexity of arc consistency. At least a rough one. Arc consistency means you will do it for all the arcs. In a graph, how many arcs can be there potentially? Order n square. So at least order n square arcs तो आप check करोगे. Now how much for each arc to check? नहीं, अब d आ रहा है ना पीछे में, n is gone. N gave you n square, now d. You can have d here, you can have. So for this guy you will check d values, for this guy you will check d values, so d square. Right? N square, d square. Anything else that I have left? But it is roughly order n square d square. Okay. Now what are the downsides of enforcing arc consistency? आसान है यार, एक सेकंड का. भाई you are doing it after each assignment. जितनी बार कलर असाइन करोगे उतनी बार ये ऑर्डर एन स्क्वायर डी स्क्वायर चलाओगे। कुछ भी असाइन किया, गो एंड चेक फॉर आर कंसिस्टेंसी, कुछ भी असाइन किया, गो एंड चेक फॉर आर कंसिस्टेंसी। सो दैट्स अ हेवी ऑपरेशन। Okay, so this is runtime roughly n square d square. Okay, but detecting all possible future problems is np hard. ये सेम वही चीज है जो हमने अभी तक किया है, डिलीट फ्रॉम टेल और वो सब चीजें। ओके, limitations of arc consistency. राइट, बताओ इस पर्टिकुलर फिगर में क्या चल रहा है? जस्ट लुक एट दिस वन। इज दिस आर्क कंसिस्टेंट? For every color there is a color here. Is this arc consistent? What about this? What about this? This one? This one? All are consistent. This one? This one? But फिर भी यहां पे क्या प्रॉब्लम है? The moment you choose red here, the moment you choose blue here, nothing is left for here. Okay, so after enforcing arc consistency, we can have one solution left, can have multiple solutions left, can have no solutions left, and not know about it. In this case it is arc consistent, but we don't know that there exist problems here actually. Okay, arc consistency still runs inside a backtracking search. So I think not yet. So what can we do? How do we solve this problem? Is this a problem of arc consistency? This is not a problem of arc consistency. This is a problem of three consistency, right? These three coloring should be consistent. So similarly you can talk about arc consistency. You can call arc consistency as what will be three consistency? Three consistency will be checking for three at once, not just for an arc, but for a clique. For a clique of, everybody understands clique? What's a clique? Complete graph of that size. Okay, so what will be a clique for these guys? This one and this one. Okay, so this is a three consistency solution will solve it, but then आपके को सामने कौन सी प्रॉब्लम आ सकती है? 4 consistency, 5 consistency. Okay, ordering, variable ordering. Right, so these 2 slides and then we go. Of course we go. जाओ। इसको बोला मैंने सिर्फ. All right, so we talk about this now. What ordering are we talking about? Right? So, what are we talking about? I've given you the whole slide. Minimum remaining values. Choose the variable with the fewest legal values left in its domain. What does this mean? So let's say I have two variables. एक में मेरे पास डोमेन में 3 पॉसिबिलिटीज हैं, एक में डोमेन में जस्ट एक पॉसिबिलिटी है. सो देन गो फॉर दी वन विथ जस्ट वन वैल्यू इन इट्स डोमेन. ओके, दिस इज मिनिमम रिमेनिंग वैल्यूज और MRV फॉर शॉर्ट. Why minimum rather than max? You know why minimum rather than max? Also called the most constrained variable. Right? Because that guy, what might happen? क्या गड़बड़ हो सकती है 3 और 1 में से? अगर आपने 3 वाले को पहले चुन लिया, they might be neighbors, right? And let's say you happen to choose a wrong color, जो उसको constraint कर देगा. If you choose this one, it is not constraining that one. Okay? Fail fast ordering, it is also called that. Now what happens in this case now? What is least constraining value? Value ordering least constraining value. पहले वाला कौन सा ऑर्डर था? नहीं, but to what? Variable ordering. Okay. What is this? Value ordering. Least constraining value. Given a choice of variable, right? Now that you have chosen a variable, that this variable I am going to color, choose the least constraining value. That is the one that rules out the fewest values in remaining variables. What does this mean? Choose that color which is least constraining on the other variables. Note that this may take some computation to determine this. For example, you may need to have to run R consistency. Okay. Combining these ordering ideas make 1000 queens feasible. So हम कहाँ से शुरू हुए थे? N queens. What DFS will do we don't know, but DFS plus backtracking in that same time could do N equal to 25. If you apply all these ideas in that same time, 1000 queens are also feasible. Okay, we are done for today. एक सेकंड बैठे रहो. $68, 87, 75, 71, okay, 84, 59, 57 या 51, 51, 10, 62, 114, 22, 50, 11, 005, 45, दिव्यांशु ओके 34, हाँ 152, 154, 21, 35, 26, 26, चैतन्य अग्रवाल ओके 115, 70, 002, 125, 113, 107, 21, 124, 63, 18, 56, 19, 48, 28, 30, 99, 004, 110, 112, 105, 72, 93, 103, 75, 64। तो चैतन्य की अटेंडेंस लगाई किसने फिर? ऑल राइट।
सर तो फिल्टरिंग तो प्रैक्टिकली नहीं है ना बिल्कुल। फिल्टरिंग तो प्रैक्टिकल नहीं है।
कौन सी फिल्टरिंग प्रैक्टिकल नहीं है?
मतलब इतना कुछ कंस्ट्रेंट सर्टिफाई करते रहो, फिर इतना अलग ही डेटा स्ट्रक्चर में घूमना पड़ेगा बहुत ज़्यादा।
एक मिनट अपन रिकॉर्डिंग ऑफ करते हैं।
सही बात है।